Problem A10. What is the remainder when 23 times is divided by 32? Now, to do this, you have to invent a divisibility rule, right? So if we know the divisibility rule of 4, last two digits are a multiple of 4, 8, which is last 3, 16, which is last 4, so we have 32, which is last 5. Or is it? Pretty much, yes. Because for 16, we have 16 times 6 to 5. This is a multiplication. You should all know how to evaluate because this is very important in divisibility. This is equal to 10,000, right? Well, we don't need to go up to 5 digits, I think. What we're gonna do, since we change this to 32, right? And that's a whole number, 625. We can make it 20,000s, right? So you get the idea of 20,000. So 20,000 is divisible by 32, right? So then we erase that, and we can look at this problem. We have 2, 3, all the way up to the last few digits, which I'm gonna write here. 6 digits. Now, if we subtract 20,000 off, or you can ignore this one really, you get 1, 2, 3, 2, 3, right? Now this number is the leftovers of, well, this is less than 20,000, so we have to just use straightforward division and divide by 32. So let's do that. Now I'm not going to do it here to save your time. If you do that, it gets you to around, well, 385, right? But then now you need to write it in remainder terms. And if you do write it in remainder terms, what do you get? Well, you get remainder free, sorry. So that is our answer, remainder free. Now it might be a bit complicated with the divisibility rule, but you can just remember that 20,000s are used for divisibility by 32. And here, since we want to find out if this is divisible, subtracting 20,000 doesn't matter because it's still divisible by 32 if it subtracts 20,000. So the remainder doesn't change if you subtract by something that's remainder 0, right? Therefore, I am going to erase all of this. So our final answer, once again, is remainder free.